Hello students, this video is designed to help with this map of geometry project. I'm going to be talking about what I expect from you for the project, what the different things are that you're going to have to be including, and any potential questions that you might have. Let's talk about the goal. I really want to make sure that you understand geometric vocabulary. There's more vocabulary in geometry than there was in algebra, than there will be in Algebra 2. Geometry is a very vocabulary heavy course. So the purpose of this project is to just make sure that you understand all the vocabulary words that I'm using in the project. Parallel, transversal, corresponding, alternate interior. All of these need to be understood by you and need to be able to be translated into a diagram. So your unique town map, keep in mind unique, that incorporates many geometric key terms. So for example, your map should be much different than the map of anyone else that's in the course. I do want to make sure that I emphasize that academic dishonesty is a serious thing. Please do not copy anyone else's map because I'm going to be looking at them and I'm going to know. Anyway, it says your town must include the following elements: 2 named streets that are parallel to each other, a diagonal street that's a transversal to the 2 parallel streets. It needs to have all of these things. Now, if I were to use this, and this is the sample layout project that I gave to you on that document, that sample layout project has a framework of a couple of streets that you could use. Then you are able to use this sample layout and say, well, I'm just going to build on this. However, I can show you that this street here and this street here are parallel. They're running alongside each other at the same slope, but they never intersect. I wouldn't be able to use those 2 streets in my section A, in my letter A. The reason I wouldn't be able to use those is because later on in the project it tells you you cannot use elements that are already given to you. As a matter of fact, let's get past this for a moment and let's talk about the project details, and then we will get back to what it might look like. It says the project should be on a standard size piece of loose leaf computer paper or graph paper. It doesn't have to be a perfect piece of paper like that. If you have a slightly smaller piece of paper, that's fine. Whatever you have lying around the house, I don't want you to go out, certainly don't want you to go out to the store or to, like some sort of like drugstore or something like that and pick up new oak tag for this or a foam core board. No, not necessary. Use whatever you have lying around the house. Construction paper, cut up cereal box, and so on. All drawings should be made by hand. I very much prefer that you do this by hand. I think that there is definitely a benefit to you drawing these things by hand and perhaps coloring them in. That is an option. It's not necessary to color anything in. But once you do that, you're helping yourself remember these vocabulary words. You're going to remember, oh, I drew an octagonal building. That octagonal building was my hospital, for argument's sake. And you're going to be able to remember that term octagonal a little bit better after having drawn it by hand. You do have the option to use the computer, but if it's your only option, as I said, I strongly prefer you to do a drawing. Name your town. It should be a unique name. Again, as I said in the beginning, the name of your town and your name should be placed at the top of the page. If you hand this in and you don't have your name or the name of your town, I will be taking points off of that. And it should be very easy to do, to write your name at least, and come up with a fun name for your town that's based on the other things in the town. We'll talk about that a little later. All of the items, all the buildings, the roads, the parks, and so on should have interesting and unique names. The post office that's in the shape of a rhombus, you should call that, post office. I guess that's fine. But a school should have a unique name. The hospital should have a unique name, whatever the case may be. Let's see, where are we at here? You can use your own neighborhood as inspiration. If you happen to live in Elmhurst, you might want to say, oh, this hospital, I'll call it Elmhurst Hospital. That's an example. You can make up something entirely new. If you want to make up Super Fun World, you can call the hospital Super Fun Hospital. You could call maybe the school, you could call it the Fun Academy. These are really bad examples. I trust you to be more creative than me. There is a legend, and I'll show you the legend here. The legend should be all of the different things that you've drawn. So for example, for item A, if you look back at the previous page, item A says 2 named streets that are parallel to each other. You would write, Mulberry Street and, Joshua Street, 2 different types of trees. Where are we at here? We're back on the first page. Label each item with its letter from the town specification list, and you're going to write down their names. None of the items have to be regular polygons. For example, It does say here we have to draw the courthouse in the shape of a pentagon, but it doesn't have to be a pentagon with all the same size sides. This is a regular pentagon. All the sides are the same. You could draw a shape that it's a pentagon that isn't a regular pentagon, right? One of the sides could be super long, and then these sides could be different shapes. Or I'm sorry, these sides could be different sizes. This is still a pentagon, still got 5 sides, still a polygon, but it is not a regular pentagon. Hopefully that makes sense. You're supposed to use marks to indicate properties of each item. For example, if I'm drawing a pentagon, it's not necessary to make any marks on it because a pentagon doesn't have to be congruent in any way. The angles don't have to be congruent, the sides don't have to be congruent. However, there are some things here, for example, as a quick hint, a rhombus, this has to have a couple of markings on it. And if you'll recall in class, rhombuses are, or rhombi, are shapes that have all 4 sides that are congruent and are quadrilaterals. Let's see, where are we up to? We said the legend part, they don't have to be regular polygons, you have to use marks to indicate the properties of each item. Your project is going to be graded based on its completion, whether you've done all of the things, its accuracy, whether all the things are correct or not, its labeling, whether all the things are labeled, and also the legend, and its presentability. I need to be able to read it or see it or interpret it in some way. Please make sure that all of these 4 things are taken into account by you while you're making your project. You can start from the pre-drawn layout. The pre-drawn layout is the thing that I showed you here. This is just a suggestion. You can print it out from your computer if you would like, but you do not have to do that. In fact, it might be easier for you to start from scratch because, as I said, if you're using this pre-drawn map, you can't use these 2 lines as your parallel lines. You can't use this as the midpoint of your line segment. You're not allowed to do it. So you would have to draw all new ones. You would have to add on things in this diagram, and that might be, not as fun. And it also might be a little bit more difficult to fit it all in. Let's see. The project is due Friday, May 29th. If you're doing this in 2020, hopefully you'll be handing it in by then. If I assign it to you another year, it may be that this may change. Please check your project for that. To submit the project, you're just going to take a picture of it and upload it to Google Classroom. Very easy. You've done this before in this class. Okay, so if I'm being asked to do this kind of thing, if I'm being asked to make these elements, it should be fairly easy for me to give you an example of what a project might start to look like. So let's take a look. All right, here I've made the specifications a little bit smaller so that I can perhaps draw a facsimile of what the town should look like here. Now, the first thing I need is some sort of layout. I need an 8.5 by 11 sheet of paper or something that sort of looks similar. Let me see if I can install that for you here. All right, here it is. Here's Mr. Scordine's project. Oh boy. And remember that you have to write the name of your town and your name on the top. So maybe I'll write a little Mr. Scordine here. And I'll also put the name of the town. I didn't really think about what the name of the town would be before I started this video, so I'll think about it right now. Let's see. Quick thinking. We'll call it Mathematicianopolis, which is quite a few syllables. Mathematicianopolis. And I'm calling it Mathematicianopolis because my idea is everything in this city is going to be based on mathematicians, and opolis is the Greek suffix for city, or polis. Town specifications. Your town must include the following elements: 2 named streets that are parallel to each other. Well, I told you that I would prefer that you draw these by hand and with a ruler. Since I don't have the ability to do that on my screen, I'm just going to use the straight edge tool here. Here is one line, and here is another line that are 2 named streets that are parallel to each other. Boom, boom. How about that? Now, I want to be careful because it does say 2 named streets, lines that are parallel to each other, and these at present are not lines. In order to make them lines, I'm going to have to make them so that they start and end with arrows, right? Lines, not line segments. That's one thing that you have to make sure that you keep track of. These are specific vocabulary words that they need, and they need to have their specific meanings attended to. All right, as it said in the directions for this project, all of the things need to be named. All these items need to be named. So we'll call this Pythagoras Way, which makes sense because Pythagoras was a mathematician. He was a Greek mathematician. And we'll have this one be Eratosthenes Drive. Eratosthenes, famous scientist and mathematician. So we'll put that here and here. And both of these should be labeled with A because A is the requirement that we're meeting here. So here's A, and here's also A. See what I'm doing? I'm writing down the things that it's asking me to put down. I'm labeling them with the letter of the item requirement, and I'm also writing down their names as a label. Now I'm looking for a diagonal street that is a transversal to the two parallel streets. Now keep in mind it is a line, so my beginning and end have to be arrows. So a transversal is a line that intersects two parallel lines. So here's my transversal. And I am going to come up with a fun, pithy name for this transversal street right now. Now here's a transversal. I could call it something boring like transversal, street or whatever like that. But again, this is Mathematicianopolis, so I'm going to call it Loveless. How about place? And Ada Lovelace was a mathematician and computer scientist. That's why I'm using her. Okay, here's Lovelace Place. It is a transversal that's intersecting both of these parallel lines, and I should keep in mind that I have to label it with the letter. Two small convenience stores that are located at a set of corresponding angles. Well, looking here, I know that there are corresponding angles in a lot of different places. Let's outline some of them here. Corresponding angles might be on the top left of this intersection, right here, and on the top left of this intersection here. These two are corresponding angles. So I can take both of these dots and say these are my convenience stores. I could also do it in other places. This angle and this angle, for example, are corresponding angles. This and this are corresponding. In all of the cases, they're on the same place in the intersection, just the other intersection. And finally, this and this, these are corresponding angles, just in case you weren't sure what corresponding angles meant. All right, so far I've done the first two. I've done the two named streets that are parallel to each other. A diagonal street that is a transversal to the two parallel streets. I can skip around a little bit. Some of them talk about having two streets that are perpendicular to each other. Okay, so that means I'm going to draw two new streets that are perpendicular to each other. And I already have Lovelace Place here, Pythagoras Way, and Eratosthenes Drive. So I can come up with two new streets that intersect here. Let's make one street, and of course it does say line, so I'm going to make one more line here. Perfect. And one more line here. Perfect. Now the reason I drew them like that is because the requirement says the lines have to be perpendicular to each other. So now I've created one triangular plot of land here, one quadrilateral shaped plot of land here, and I can subdivide this plot of land into whatever I want based on what structures need to be there. I'm going to extend these a little bit further so that they reach the edges of the paper. I think that's only fair because they are lines that go on forever. And these two streets are now perpendicular to each other. Remember, you have to name them. It says two streets that are perpendicular to each other, and that's letter F. So I'm going to say here's F. And I have to name them with the names of some mathematicians, some famous mathematicians. So I can use, let's see. We could use Florence Nightingale, who is a statistician. So we could say Nightingale Street. And this street here, which is perpendicular to that street, let's see, it's still letter F because we're meeting requirement F. We could use Dorothy Vaughan, who is a NASA pioneer. So we could say Vaughan. I don't know. How about Way again? It's just very creative what I want you to do, and you can use whatever you want. If you want to call it way, if you want to call it street, place, it's up to you. I don't want to quell your creativity. Let's do a couple more things before we finish here. All right, I chose Nightingale Street for Florence Nightingale. She was a statistician. And Vaughan Way for Dorothy Vaughan. She was a NASA pioneer. All right, so we are labeling both of those F because that was the requirement F. Two streets that are perpendicular to each other. And now let's take a quick look at some of the other things. It says draw a path or a bridge that connects two complementary angles. You know that complementary angles are two angles that add up to 90 degrees. So from here to here, for example, these two angles would be vertical angles, but they're not complementary because this angle and this angle do not add up to 90 degrees. They actually add up to 180 degrees. So you might have difficulty trying to figure out what way we can draw this path. I'm going to draw it for you and then show you so you can figure it out yourself. All right, it does say complementary angle, so you know that a complementary angle has to be or two complementary angles have to be adding up to 90 degrees. So I'm going to add in one street here. This street is not going to be a line, it's just going to be a line segment, but it does split up this right angle into two specific angles, and these two angles are complementary. They add up to 90 degrees. So what I have to do is create a, where am I at here? A path or bridge that connects these two complementary angles. Keep in mind that this is a street. This street is, could be a busy intersection, could be maybe a highway or something like that. And we don't want people to necessarily go from this side of the street to the other side of the street without being careful. There could be a pedestrian overpass here. You see pedestrian overpasses all the time in different sections of Queens. So I'm going to make a path or bridge that connects the two. Let me just use a little curved line here. Here's a curved line. I'm just going to switch it around a little bit. Now for you, this is going to be very easy because you're not going to have to deal with a computer drawing program. All you're going to have to do is draw it yourself. So here's my bridge. I'm going to make it a different color so it looks a little bit different than the rest of the thing here. And this bridge connects these two angles, which are complementary, which means they add up to 90 degrees. So this is the path or bridge that connects two complementary angles. This is requirement K. So I'm going to label it as such, K. And now this bridge, that's an interesting thing to name. Here's an idea. Let's call this Königsberg Bridge. And the reason I'm calling this Königsberg Bridge is a very good reason. Königsberg was a mathematician, way back in the day, and he was famous for the so-called bridge problem, which talks about how many times you could cross over certain bridges that go to an island in his hometown, and whether you can do it without crossing the same bridge twice. Königsberg Bridge, very good name, starts with a K. Sometimes it just falls right into your lap. Last but not least, I'm going to pick one of these buildings to draw. It does say, draw a hospital in the shape of a parallelogram and place it at an intersection with a right angle. It looks like I'm fresh out of intersections with right angles, so I have a couple of options. One option that I have is to redraw a couple of my lines. For you, it might require a bit of erasing, but for me, it just requires me to shift it around a little bit. That's one option that I have. Another option is to make a brand new street that has a right angle. A third option could be moving this bridge around, but I've already made this bridge. Don't think I want to change it. So I'm going to try to make a hospital in the shape of a parallelogram and place it at such an intersection. Here's what I'm going to do. I'm going to shift this street around just a little bit. I'm going to shift it like that. And I'm going to say that this is a right angle. I have to do a couple of things. I have to mark it as a right angle. So I'm going to do that now with these lines here. Bada bing, bada boom. And I'm going to place a hospital here. I'm going to make the hospital, it tells me to be a parallelogram. So I'm going to draw it in a slightly different color. Let's draw it in blue. And there are lots of different types of parallelograms you could draw. One type of parallelogram is the classic type of parallelogram that looks like a lazy rectangle, right? A leaning over rectangle. So it could look just like this. Keep in mind that parallelograms are very vague. You could have lots of different types of parallelograms. You could have a parallelogram that is also a rectangle, a parallelogram that is also a square, a parallelogram that's also a rhombus. The sky's really the limit. Now, the last thing I'm going to do for this is I am going to label it with its name. I told you that it has to be a hospital, told you it has to be the shape of a parallelogram, and I told you that it has to be at an intersection with the right angle. Let's name this thing. This is a hospital, and we know that this is a requirement N, so I'm going to label it with N. And the hospital's name, let's think of a mathematician that had something to do with math and also had something to do with medicine. How about we go with Avicenna Memorial Hospital. Avicenna was a Persian mathematician. They called him a polymath because he was basically good at everything. He wrote books about the first modern medicine. Or I guess ancient medicine. Moving on. Here's a basic layout of the first couple of things that we've done so far. Then keep in mind, we've done only a few of the requirements. We've done two named streets. We've done a diagonal street. We've identified a hospital, which is here, letter N. We've identified two streets that are at right angles, that are perpendicular to each other. And we have Königsberg's Bridge. So we only have 1, 2, 3, 4, 5 of the requirements, but keep in mind it only took me, maybe 5 minutes to put this together. The rest of the project is just going to be me placing different things onto this map and labeling them with their labels, their names, and making sure that they meet those requirements. So hopefully this makes sense to you. Again, this was a video about the geometry project, which is called Map of Geometry. Good luck studying.